Hi guys, so we are going to be doing the 3.03 Solution Formation Lab. We're going to start with an introduction and some background information. Several factors affect a substance's rate of dissolving or dissolution rate. In this lab exercise, you will alter two factors as you create solutions. You will also apply the concept of collision theory to understand the significance of your results. Factors such as temperature and surface area can influence the rate of solution formation. Temperature and surface area can influence the rate at which a solid solute dissolves. This concept may seem easy to understand, but it is an important one for chemists who need to characterize the relationship between temperature and dissolution, and between particle size and dissolution, in many types of lab procedures. When salt dissolves in water, for example, the temperature of the water and the surface area of the salt crystals influence the rate at which the salt dissolves. The knowledge that dissolution can be explained in terms of particle collisions is called collision theory. This theory states that the particles that make up any solute or solvent are in constant motion. When solvent particles collide with solute particles, dissolution is the result. Suppose you want to sweeten some lemonade. Which would sweeten it faster, a lump of sugar or a spoonful of granulated sugar? Would a sugar cube dissolve faster in hot lemonade or cold lemonade? If you know the answer, well, let's go ahead and see if you're right in the lab that we're going to do. After having made this observation, you can ask the question, what are the factors that affect how fast a substance dissolves? In this experiment, we will first dissolve table salt in water, noting how long it takes salt of different particles to dissolve. Then we will explore the time needed for salt to dissolve in water at different temperatures. All right, so for experiment number 1, we're going to be looking at the effects of particle size on solution formation. I have everything set up. I have labeled the vials 1, 2, and 3. And we're going to start out by measuring our amounts and different types of salt to go in each vial. So in vial 1, it's already 5 grams. For the rest, we're going to have to measure out the 5 grams, but we put it there and I already tiered it. So we're going to put this in vial 1. In vial 2, we're going to measure out 5 grams of coarse grain salt. We're at 2, 3, 4, and not quite 5. Okay, so we measured out 5 grams of the coarse grain, which is vial 2. Vial 1 was the pellet salt. And in number 3, we are going to put fine grain salt. 5 grams of that also. And almost 5 grams. Okay. Put that in here. So vial 3 is the fine grain salt. Okay, so for the next part, we are going to add 20 milliliters of tap water into each vial. So that way that is a constant and remains the same for all 3 of them. And I'm just going to measure it using a beaker. we are going to put the lids back on. So number 1 again was the pellet. Number 2 is the coarse grain salt. And number 3 is the fine grain salt. And now we're going to allow ourselves up to 45 minutes to see at what point they dissolve. So I will see you back in 45 minutes and we will report back on the outcome. Okay, so it has been 45 minutes and we are back to see our observations on what has dissolved, or if anything has dissolved. And if you look at vial 1 with the pellet, this is what it looks like. You're going to record your observations in the chart. It will look similar to this. This is vial 2 with the coarse grain salt. And then this is vial 3 with the fine grain salt. Okay, so for part 2, we are going to look at the effect of particle size on solution formation with agitation, meaning we are going to shake the vial. I've pre-measured out our 5 grams of each again, so we're going to start with 5 grams of the pellet salt, 5 grams of the coarse grain, and then 5 grams of the fine grain. And we're also going to still add 20 milliliters of water. So I'm going to start by adding the salt to each that I've pre-measured out. And now we're going to add the 20 milliliters of water to each one. There we go. Okay, so our next step is we are going to, basically our goal is to measure and record the length of time it takes for the salt to dissolve completely in each vial. And so I am going to agitate this, and we're going to revisit this in 2 minutes to begin with. Okay, so it has been 2 minutes of agitation on the vials, and this is the chart that we were looking at. So we are wanting to see our observation at 2 minutes, then we're going to check it again at 5 minutes of agitation, and then 6 minutes. So right now, vial 1 with the pellet looks like this. Vial 2 with the coarse grain salt looks like this. You can still see some at the bottom a little bit. And then vial 3 with the fine grain salt is getting pretty clear. There is still some in the bottom there. And now I'm going to agitate that for another 3 minutes, and we'll check this again at 5 minutes. Okay, so we are at 5 minutes now, and I'm going to take a look at the vial number 1 now with the pellet. This is your observation. Vial 2 with the coarse grain salt. You can still see particles floating around there. It is dissolving some. And then vial 3 is getting pretty clear. Oh, there you go. It's a little bit better, but still not fully dissolved. Okay, so we are going to now revisit this in another 2 minutes. No, 1 minute. And then we will record our final observations. Okay, we are now at a total of 6 minutes of agitation, and these are our final observations. Here is vial number 1 with the pellet. As you can see, it is not fully dissolved. Vial number 2 with the coarse grain, it is almost dissolved. You can still see a little bit there. And then vial number 3 with the fine grain has nearly fully, or if not fully, dissolved. You can see how clear it is there. And then we will now be moving on to our final section, part 3. Okay, so part 3, the last thing we're going to look at is the effects of temperature on solution formation. And you will have a chart that looks like this. And we're going to, I've already pre-measured this out, so I've got 5 grams of coarse grain salt in each vial. This time we are keeping that as a constant. And the first one we're going to look at is the coarse grain salt with ice water. And so we're going to add 20 milliliters of the ice water to the vial. So look, and I've got the ice water here. Vial 1. Put the lid on. So I am going to shake this for 5 seconds every minute until the salt has completely dissolved. And then we're going to observe and record the time needed for the salt to dissolve. Okay? Okay, so for vial number 1 with the ice water, it took approximately 6 minutes for it to dissolve. So in our chart over here, I'm going to record 6 minutes. And then the next one we are going to do, we're going to move on to salt, to the salt and room temperature water. Okay, so in vial 2, we still have coarse grain salt, and we're going to add our 20 milliliters of room temperature water. And then we are going to do the same process. We're going to see, with shaking it for 5 seconds, or agitating it for 5 seconds per minute, how many minutes it takes it to fully dissolve. And now we'll be back with the results. Okay, so for vial number 2 with the salt and room temperature water, it took approximately, it is dissolved now, it took approximately 4 minutes for it to fully dissolve. So we're going to record that in our chart. And the last one we're going to look at for part 3 is the coarse ground salt with hot water. Okay, so again, I've pre-measured out the amount of salt, and I have hot water, and we're going to add 20 milliliters of the hot water to the vial. And then we're going to use the same process where it's going to be agitated for 5 seconds per minute, and we're going to see how long it takes vial 3 to dissolve. So for vial 3, it was approximately 2 minutes for it to dissolve. You can see here, it's fully dissolved. So record your observations, and again, it was 2 minutes, and I have recorded that here in the chart. And now you're going to be moving on to your discussion questions, and think about what we've talked about in class as far as kinetic energy and heat. And that's it.